link state routing with OSPF. OSPF is a link state IGP, and it can support medium and large enterprise network. It is the most common IGP. We will explain the OSPF convergence process, describe the different network types supported by OSPF, and also configure single area OSPF network. OSPF stands for Open Shortest Path First. It is a link state protocol. It can detect topology changes within the AES autonomous systems and establish loop-free routes in a short period of time, with minimum additional communications overhead for negotiating topology changes between disappearing routers. It uses area to manage scope of router communication, and it can provide a rich route matrix. We know RIP only have the hard as the metric, but OSPF can take account into the calculation of such as the bandwidth delay. OSPF convergence behavior. So OSPF routers first establish adjacency between their neighbor routers, and use LSA, it's called link state advertisement, to share the network information and eventually build a link state database, LSDB. From this database, each router can calculate the shortest path to each network. Router ID. Router ID is a 32-bit value to uniquely identify the router within the OSPF domain. We recommend to assign this router ID manually. If you don't assign it, the router will pick up the highest logical IP address, such as the loopback address. And if you don't have any loopback address configured, it will pick up from the largest physical IP address configured on the router. But in order to manage your router properly, again, you should assign the router ID for each of your OSPF router. So when the router see his own router ID in the hello packets, they transit to two-way. When the router in the exchange start state, the router and its neighbor establish a master and slave relationship and determine the initial database description sequencing numbers in preparing for the exchange of database description packets. The neighbor with the highest router ID becomes the master. So in this decision state, they are ready to exchange. In this state, the router sends the database description packets describing his entire linked state database to his neighbor. Loading is the router sends linked state request packets to his neighbor are in the loading state. So full means the neighbors are fully adjacent, and the adjacency appeared in router LSAs and the network LSAs. Neighbor discovery. Hello packets will be sent to the neighbor in order to discover the neighbor, maintain the two-way communication between neighbors. Here is an example of hello packets. So it has hello interval 10 seconds, hello interval options, router priority, router dead interval 40 seconds, DR, VDR, and the neighbor. This is sent from router 2 to the destination 224.0.0.5, which is the multicast address for DR. So by default, the hello packet should be sent 10 seconds for the broadcast and the point-to-point network. For the point-to-multipoint, the hello interval is 30 seconds. Another timer is called dead interval. It's valid before the neighbor is considering lost. Must also be defined. This is carried as the router died interval within the hello packet, just like we say. So basically, it's 4 times the hello interval by default. So 40 seconds for the broadcast and point-to-point, and 120 for NB, MA, and the point-to-multipoint networks. The package we saw before is less between this is on the Ethernet interface. So it's 10 for the hello and 40 for the dead interval. DR election. DR is elected based on the priority value. This priority value is set as 1 by default, and a higher priority presents a better DR candidate. If a priority of 0 is set, this router will no longer participate in the election to become the DR or VDR. BDR. So the BDR forms adjacency with all the other routers and also became the DR if the existing DR fails. You see this DR priority has been changed to 255. So, and this BDR is priority is 1. This router A will never be able to become the DR or BDR because its priority is 0. Database synchronization. Neighboring routers form a master-slave relationships. Data descriptor packets contain RSA header information. Here is an example of the database description. You can see these packages, OSPF, database description, options, that's all the options. And also you see this is the master. And the database description sequencing numbers. Also it has RSA headers. You can have more than one RSA headers. So the missing or newer instance of RSA are request using LSR, link state requirement. The entire requirement RSA is sent as an update. You can see on the left, it is request. On the right side is the update. You see the message type, LS request, LS update. If there's a DR or BDR, they address all short path first routers, which is 224.0.0.5. All DR routers 224.0.0.6, which means the destination IP address for the link state update. If it's DR or BDR, use this address, otherwise use this address. On the non-broadcast networks, separate LS update packets must be sent as a unicast. If you use the destination IP address is the neighbor's IP address. So if the database description process has completed and all link state requirements has been satisfied, the database are synchronized and the router are marked fully adjacent. At this time, the agency is fully functional and is advertised in the two routers, router RSAs. Ospf metric. The cost metric is based on the formula of 10 power 8 divided by the bandwidth. The bandwidth reference command improves metric accuracy. Accuracy means You can change this number here. So there's an example. So the reference value of this bandwidth by default is 100 meg. So you can see for a 64K bit serial port, the cost is 1,562. But nowadays we have like a 1 gig or 10 gig interfaces. So if you use 100 meg as the reference, 1 gig, 10 gig, they all have a cost of 1. So you can change this to like to 10 gig, which is the 10 power 10. So which you have a cost of 1 for 10 gig interface, 10 for the 1 gig interface, 100 for the 100 meg interface. Also, you can manually configure the cost for each interface. Shortest path tree. A router that achieved a full state is considering to have received all LSAs and synchronize his link database LSDB with that of the agency neighbors. So from there, each router will rely on its own information in the LSDB to independently calculate the shortest path to each destination. The calculation of the shortest path tree independently means each router must utilize additional resource to achieve this operation. OSPF areas, single areas. Single areas is there's a single link state database for the administrative domain. You can use any number for the this area, but area 0 is recommended because area 0 is always the backbone of OSPF. Just in case you need to add another area, so your area 0 don't need to be changed. All the routers in the single area will have an identical database. Since the router multi-areas, since the router in one area have an identical database, so if you have separate areas, one thing is the router in each area just need to maintain smaller database, also minimize the impact of that change. The router has interface in more than one area. It's called ABR. It's called Area Border Router. ABR should have a link in area 0. So it will advertise the routing information from one of these areas into area 0 and through the area 0 into another area. OSPF network advertisement. Here we will show how to configure OSPF. So under the system view, you run OSPF, the process ID, which is 1 here, and specify router ID. In this case, it's 1.1.1.1, and you specify the area number, area 0, which is the backbone, and you use the network command to advertise the network you want to advertise. 192.168.1.0 is the network address, and the 0.0.0.255 is the wildcard. So the 0 bit represent the network, and the 1 bit represent the host. Configuration validate. Display OSPF pair. So from the output you can see the error is 0, interface is 192.168.1.1, and his neighbor router ID is 2.2.2.2, address is 192.168.1.2, and the state is 4. It's also the neighbor is the master, has priority 1. Also this have a DR and the BDR. So here's the DR, here's the BDR. Also it has timer. So neighbor is up for 31 seconds. So by checking this number, you can see how stable your neighbor is. The longer the network is more stable. OSPF certification, like the RIP, under the interface, you can run OSPF certification. You can check the mode. You can use mode. You can use the simple password, or you can use mode crypto password, which is MD5. It's the keychain and also the password or key. Configuration validation, terminal debugging, debugging OSPF packet. You can see the so router A source address 192.168.1.1 is sent destination to the 224.0.0.5, which is DRBDR multicast IP address. Area 0 is area 0. Authenticity type 02. You can see the key. That's for the authentication. OSPF silent interface. You can go to interface. You can go to the OSPF process and silence the interface. So silence interface command prevents an interface from forming neighbor relationship with peers. So this is particularly the case we are connecting with external networks. So you want to protect your internal routes. So basically the hello packets on the interface will be blocked. So no neighbor relationship can be established. So silence interface all will basically ensure that the all interface and this OSPF process will be restricted from participating in OSPF. We can validate the configuration. Command display OSPF process 1 interface 000. You can see silence interface, no hellos. Questions. What is the purpose of the dead interval in the OSPF header? The dead interval is a timer value that is used to determine whether the propagation OSPF hello packets has ceased. This value is equivalent to 4 times the hello interval. 40 seconds by default on the broadcast. So in the event that the diet interval counts down to 0, the OSPF neighbor relationship will terminate. In a broadcast network, what is the multicast address that is used by the DR and the BDR for listening for the link state update information? So DR and the BDR use the multicast address 224.0.0.6 to listen for link state updates, while the OSPF network type is defined as broadcast. This is all about OSPF. Thank you for listening.